The aim of this experiment is to verify the laws of reflection of sound. The material required is a drawing board, white paper sheet or a drawing sheet, pins, a stop clock, any smooth reflecting surface like a board or even a wall is perfectly fine. You can use a wall for this. A mirror or a metal plate with a holder. Chart papers for making pipes of 30 to 50 centimeters length and 3 to 5 centimeters diameter of a PVC pipe of similar dimensions. So you can either use chart papers for making pipes or you can use PVC pipes having similar dimensions. We'll be setting up the apparatus as shown in this figure. This is the reflecting surface. You can use any metal block or like any wall also can help for this purpose. Place the pipes at an angle to each other in such a way that this center partition, which is the screen, which is generally made of wood, acts as a normal that is perpendicular to the reflecting surface. So the angle between the first pipe and the divider or the normal should be equal to the angle between the second pipe and the divider. So as you can see in this image, 30 degrees is the angle formed between the incident ray of sound and 30 degrees is the angle formed by the reflected ray of sound. So we have placed a small stop clock over here. The sound wave will travel through the pipe. It will hit the reflecting surface, bounce back and travel back through the second pipe. And if we place a ear here, you should be able to hear the sound. So this is how we prove that sound is reflected using the same laws as the law of reflection of light. Let us understand this. So the law of reflection of sound is that the incident ray or the angle of incidence is equal to the angle of reflection. Let us perform this experimentally now.
So I have placed these two hollow pipes in such a way that they are making equal angles with the normal. So if you look closely, we have a protractor or a D placed here. So this is 90 degrees. So you can imagine that this is the straight line which is going to be the normal. So from 90, 50 on the left and 50 towards the right. So the angle that this pipe makes with 90 degrees is the angle of incidence of sound, and the angle that this pipe makes with the normal is the angle of reflection of sound. So I have placed a stopwatch here which will produce a very low tick-tock sound, and if you place your ear at this point, you will be able to hear that sound very clearly. So this shows that for sound, the angle of incidence is always equal to the angle of reflection. So I have placed a board here which acts as a reflecting surface. You can also use a wall, and if I change this angle, let's say I decrease it to maybe 30 degrees. So from 90, it's now at 30 degrees. Again, if I change the position of this watch also, you'll be able to hear the sound if you place a ear here. But if I make it a mismatch, 30 degrees here and 40 degrees here, then you will find that the sound will not be able to reach your ear, because as I said earlier, the angle of incidence is always equal to angle of reflection for sound waves.
Let us record the observations. Initially, when we measured the angle of incidence to be 30 degrees, so from the experiment we observed that the angle of reflection of sound is also equal to 30 degrees. So is angle I equal to angle R? Yes, angle I is equal to angle R. So there is no error here. We tried it the second time, placing it at an angle of 40 degrees, and we observed that the angle of reflection was also 40 degrees. So in this case also the angle of incidence was equal to the angle of reflection and there was no error. So you can try it out with 3 more different angles and fill in the table in a similar way. The results showed are that the angle of incidence of sound is equal to the angle of reflection of sound within experimental limits. So it may be a deviation of a few degrees left or right, but on the whole the angle of incidence of sound has been proved to be equal to the angle of reflection of sound. Since the incident sound ray and the reflected sound wave at the normal lie on the same drawing sheet, so we can say that these rays they also lie in the same plane, and thus the laws of reflection are verified using this experiment.